Okay, I figured I'd just start with this problem right from the beginning again. I'm home now and watching the Phillies. It's tied. Hopefully they'll win it in this inning. Okay, here we go. Let's try this. Remember what we're going to do? We're going to do a little substitution. So we don't want this 6z to the fourth, and well, that was a squared. And we don't want this one squared. We actually want this to be just one variable and this to be something squared. So we would rather have this z squared and z. But I'm not going to use the same letter. What I'm going to do is I'm going to replace it. I'm going to let, and we're going to write this down, we're going to let x equal whatever this middle term is right there, so z squared. So watch what this is going to be. Instead of z to the fourth, remember, x is z squared, so z to the fourth would be the same as z squared squared. Right? So if z squared is equal to x, this is really x squared, so it's going to be 6x squared. Ooh, Philly's just got a hit. Good. Minus, and then this is going to be 13. Remember, we took z squared and we set it equal to x, so that's going to be an x right there, minus 5. So what we're going to do is we're going to solve for x here. It's a little easier because it's a regular trinomial factoring like we've been talking about. It's a something x squared minus something x and then plus or minus something, not z to the fourth z squared. So we're going to factor this, but then when we're done, we got to don't forget about this thing right here. Okay, then we have to put it back in. This is by substitution. So this is just a regular trinomial factoring. So let's give it a shot. Let's see what it is. We got a couple choices with 6. We've got 6 times 1 or 3 times 2. I'm just going to go 3 times 2. Now, I haven't even looked at this to see what the answer is. So we're just going to try some numbers. This is just me trying it off the top of my head. Now what's the signs going to be? Well, they multiply to be negative, so that means one is positive and the other is negative. So 5 and 1, I'm kind of limited in my choices there, which is a good thing. So I can go 5 times 1. Or I can go 1 times 5. I don't know what actually works. We're just going to play around with this and see what actually works. So we know the first works. 3x times 2x is 6x squared. We know the last works. Positive 5, negative 1 is negative 5. It's the outside and inside has to add up to be negative 13. So let's do that. Let's do the outside. That's negative 3, or negative 3x. And the inside is plus 10x. Well, that's a 7x. That doesn't equal negative 3x. So that's not going to work. So we're going to get rid of that. And let's get rid of this and get rid of this. Let's try just switching up maybe the positive and the negative. So let's make this negative this time and make this positive. I don't know. That might work. Let's see what happens. And it might not. We might have to try some other numbers. So again, the first and the last are fine. If you check them out, it's 6x squared and the last is negative 5. It's the outside and inside. So the outside is 3x and the inside is negative 10x. That's a negative 7x. That's not going to work either. So let's get rid of that. Let's try something else. Let's try moving around the 1 and the 5. Let's put the 1 here and the 5 here. And let's see if that works. So, I think we're getting close. Watch, 3x times 5 is 15x. And then the inside is negative 2x. Well, that's a positive 13x. That's close, but not exactly. So it might work. It might work if I made this positive and I made this negative. Let's see if that works. Let's get rid of this. Alright, so now let's do the outside and inside. The outside would be negative 15x, and the inside would be plus 2x. Alright, good. So I actually had to try that about, what, 4 times, maybe 5 times, something like that, 3, 4, 5 times, and to get something to work. So that actually does come out to be negative 13x. So this, now I don't need this anymore, so this actually comes out to be our factored answer, almost. Because remember, we're not really doing this with x. We're doing it with z. Right? Remember what x is equal to? X is equal to z squared. So let's replace this with a z squared. So it's going to be 3 instead of x. Remember what x is equal to? It's z squared. So I just replace this with a z squared. That's really what there is, all there is to the substitution. And then 2 times x. Again, remember x is z squared, so I'm going to put a z squared right there. And minus 5. And there we go. There is our factoring. So we did it by substitution. We looked at this and we said, it kind of looks like that trinomial factoring. It's not quite it. So what I did was replace this with just an x. See that? But if this came out to be an x, then z squared squared would be z to the fourth. So that would be x squared. All right, I hope you see that. Sometimes it takes a little while to see it, but there you go. So let's do another one. All right, here's another problem. And as you see, it kind of looks like what we've done before, except look at this thing right here. That's the x, and that's the x right there. So we don't want it to look like this, because that doesn't look very familiar to us. So we want it to look like 10x squared minus 19x minus 15. So let's write it like that, 10. So this is going to be the x, right? Squared minus 19, since this is the same thing as this. This only works when this and this are the same thing. X and then minus 15. So what I'm going to do is over here is I'm going to write let x equal 2a minus 1. Alright. Now we're going to just factor. So just do some regular factoring. And maybe we'll get a little luckier than we did before. So I've got a couple choices. I've got 5 times 2. I've got 10 times 1. Right here I've got a couple choices. I've got 5 times 3, or I've got 15 times 1. So let's just try a few. Again, I haven't seen the answer to this yet, so I'm on my own just like you are. One's plus, one's minus, just like we did before, because it has to multiply to be a negative. Now 15, I got 5 times 3, or I've got 19 times, or 15 times 1, so let's just try 5 and 3. See how that works. Alright, so let's see what we got. We got the first is 10x squared, the last is negative 15. It's the outside and the inside that we want to try to figure out. So let's look at the outside. The outside, I'm not going to write this down, we'll just do it in our head. The outside is negative 15x, and the inside is positive 10. Negative 15 plus 10 is negative 5, that's not that. So we got to change some things around a little bit. Let's just change the 5 and the 3. Let's put the 3 here and the 5 here, see if that makes any difference. So I've got 5x, and why did I do that? I just did it because it was just something to try. That really is it. So it's 5x times negative 5 is negative 25 plus 6. Oh, there it is. I'll write this one down. Negative 25 plus 6. Negative 25x plus 6x is negative 19x. It's perfect. So I got it on the second try. Kind of got lucky on that one. And that's our factoring. But we're not done yet, because remember, we have to do our substitution. Because this obviously does not equal this thing right here, because there's no a's or anything like that in here. So I'm going to have to redo my substitution, put this back in. So if x is equal to 2a minus 1, I'm going to replace that x with a 2a minus 1. It's being multiplied by 5, so it's going to be 5 times 2a minus 1. And then just finish off the rest of it. That's a plus 3. Close that parentheses. Do the same thing with this one. It's 2 times x. There's 2. Got to put it in parentheses because it's being multiplied by 2. Got 2a minus 1. And then minus 5. Now we're not going to leave it like this because it looks like there's going to be some things that simplify here. So let's distribute the 5 through this. So that's a 10a. So this, and then minus 5. And then you got that plus 3 on the end. You see you're going to have to add those up. We'll do that in the last step, and then we'll be done. It's as easy as that. Multiply those together. That's 4a. Distribute, minus 2, and then minus 5. Alright, scooch that up a little bit. And let's simplify. So we've got 10a. Negative 5 plus 3 is negative 2. 4a. Negative 2 minus 5 is negative 7. And then that's it. That's all you got to do. Let me see something here. They write it a little different than I did. Oh, I see what they did. I'm fine with this. This is perfectly fine. I'll just show you what they did. I know you don't have a book, but this is what they did with this 10a minus 2. They actually factored out a 2 from this. So technically, yeah, this is not completely factored, because this thing right here, this one parentheses, can be factored a little bit more, right? So if you look at this one parentheses, there is a common factor of 2 in here. So if you factor out a 2 from this, you get 5a minus 1. Now, there's nothing in common with this, so I can't factor out anything from there. So I just do that. So now this is completely factored. This probably will be a better answer than this, because this is not completely factored. So yes, I do believe I would like that as the answer. And let me see. I got one more to do. Alright, this problem right here is just like the one we did in class today. But we hadn't really officially taught the substitution yet. So let's do this. Now we know a little bit more about substitution. So now let's do this the way that we've been learning. So this would be a lot better. Now this is not one of those trinomial factorings. This is a sum of two cubes. But if you look at this thing right here, this thing is being cubed, and you are actually cubing something to get this. It's 2 cubed. So what I'm going to do, though, is I'm going to replace this. Instead of 2a minus 1, that kind of becomes a pain. It's a lot easier if we look at this as x cubed. Right? So how do you just make that x cubed? Well, I come over here and I say let x equal 2a minus 1. This might be the exact same problem, I can't remember, but we let x equal 2a minus 1, and now I can make this into an x, so it's going to be x cubed. Plus, I'm going to rewrite this as 2 cubed. Now this looks like a sum of 2 cubes. So just a reminder on the sum of 2 cubes. Remember that? It's a cubed plus b cubed, and then we put the 2 parentheses. Always do the signs first. Same, opposite, positive. A and b go here. A squared goes here, b squared goes here, and then ab goes in the middle. So remember that formula right there. This works just very, very easily with this formula. So it's going to be 2 sets of parentheses, and then do the signs, same, opposite, positive, and let's put our letters in here. Instead of a and b, we have an x and a 2, and you just put them in the same exact spots. So there's an x here and a 2 here. Square the x here, square the 2 here. So that's going to be x squared. This is going to be 2 squared. What's 2 squared? Well, it's 4. And then we go ab, or x times 2, or 2 times x. So we're going to write it just like that. All right. Always look to see if this thing factors. Sometimes they will have that factor, but this actually does not factor. So you can keep trying numbers all you want, but that's not going to factor. All right, so we'll just keep that like that. But don't forget our substitution. We let x equal 2a minus 1. So anytime you see an x here, you're going to stick in the 2a minus 1. So let's do that. So this x is 2a minus 1. Continue the rest of that parentheses, put the plus 2. Now we got to do this, x squared. So what is x? It's 2a minus 1. So you put the 2a minus 1. I'm going to put that in parentheses since we're squaring it. Minus 2. Now since that x is being multiplied by 2, and x is a sum right here, I'm going to put that 2a minus 1 in that parentheses. And then you just continue the rest of it plus 4. So all I did, look, I just replaced that x with a 2x, or 2a minus 1. I took that x right there and replaced it with a 2a minus 1, and I took this x and I replaced that with a 2a minus 1. Now that looks just a little bit ugly, so let's clean it up a little bit. So let's do this parentheses first. Let's just simplify what's in here. Well, that's a 2a. Negative 1 plus 2 is positive 1, so I just put a plus 1 there. Alright, let's do the stuff in this parentheses. 2a minus 1 squared. Now, if you want to, you could go off to the side and go 2a minus 1 times 2a minus 1, and then do the FOIL on this thing. So it's going to be 4a squared minus 2a, which is minus 4a, and then plus 1. You might be able to do that in your head, but if not, do it off to the side. So it's 4a squared minus 1 minus 4a plus 1. Alright? Continue the rest of this. And the reason I'm going to do this, because look, I realize that I'm going to have an a term right here, and when I multiply this, I got an a term, plus I have a constant. You're going to be able to add some like terms together. Let's distribute this through. Negative 2 times 2a, negative 2 times negative 1. That's negative 4a. And this is positive 2, because we distributed the negative as well. And then don't forget this plus 4. Alright, we're almost done. It's 2a plus 1. And then we just add like terms right here. Any other a squareds? Nope, so we just write 4a squared. Any other a terms? Yes, minus 4a, that's minus 8a. So I'm done with that one, done with that one, done with that one. Now, add the constants. This is a 1, positive 2, that's a 3, plus 4, that's a 7, so it's a positive 7. And there it is. Now it's completely factored. And we started off by doing substitution. Right? Instead of going from here directly into this thing, you could have done that, right? Anytime you see an A, you could put 2A minus 1. Anytime you see a B, you put a 2. So yeah, you could have done that. Sometimes this is a little bit easier going this route. Alright? So that's it. That's all the substitution problems, and I hope that helps. Good luck on those.